Welcome to Halfmoon TechLabs. We're down in the brew lab today because I want to compare a couple of home brewing style pumps, one being the Chugger, the other one a Blichmann Riptide. Now it doesn't really matter whether you brew with malt extract or you're an all grain brewer, you use gas or electricity. At some point you may want to, if you haven't already, incorporate a pump somewhere in your brew day. Now you could use that for any number of things. If you have a 3-vessel system like I have here in the background, in the hot liquor tank, for example, you can use it for mixing your water while you're heating, adding your brewing salts, getting all that dissolved in, and then transferring it over to your mash tun. In the mash tun, of course, after you transfer, you have your Vorlauf and sparging steps, and then you want to transfer over to your boil kettle eventually when you're done mashing. In the boiled kettle, of course, you can use it for whirlpooling. So some people could use a pump for any of those or all of those reasons. I use it for all of those reasons. You may choose to just have it as a utility pump to do one or the other or all of the above at some point. So what are the pump choices out there? Well, again, what we have in front of us here is a Chugger. Now this happens to be the CPSS-C1-1, which is the 120 volt US stainless head version of this pump. It has a few different configurations that are well known. It's been around a long time. It's been a workhorse in the brewing and the home brewing industry for quite a while. But there are some other offerings out there. One, do you have one of these? I have one of these. It's a Blichmann Riptide. Blichmann Riptide, they kind of up the game a little bit. Now we'll go over the specifications here in just a minute. The specs aren't too different. There are some subtle differences, but the main thing is the construction of the Blichmann Riptide. So unlike the Chugger, which has a stainless head, it's a magnetically driven impeller. It has an air vented motor. And no switch on it whatsoever. This is just a good utility pump and works pretty good. Both these pumps work in about the 7 gallon per minute or 26, 27 liter per minute flow rate range. That of course depends upon the length of tubing and how many valves and how many other restrictions you have, but on paper at least they're good to 7 gallons a minute, give or take. There's another specification, the head that the pump can pump against. This Chugger is, just for example, is rated at about 18.6 feet of head, which is about 5.7 meters. And this is where the Blichmann Riptide departs a little bit. It has a little higher head. It can go to 21 feet of head or 6.4 meters. And so that can help if you have some resistance that you need. You still need to develop pressure against your plumbing circuit. So these are the two pumps that we're going to take a look at. And further down the road, I'm also going to, not in this video, but in the next video, after we're done testing these side by side in sort of a real world type comparison, where we're going to be pumping hot water through this test circuit and compare these things side by side. When we're done, I want to take the Chugger, and Blichmann now offers a Riptide upgrade kit for Chuggers and March pumps specifically. And so I'm going to take this pump after we've done this side-by-side comparison and gathered our data. In a second video, I'm going to convert this Chugger to the Blichmann Riptide, and then we'll repeat that test with the now modified Chugger and see how it stacks up against the other two sets of results we had from this video. So let's take a look at that. Before we begin our test, I want to explain briefly how the test stand itself is set up. We have basically a hot water heater set up over here. We have a brewing controller driving a 5500 watt element inside this tank, and we have the pump itself, which will be recirculating the water as it's heating. I have incorporated about 2 meters or 6 feet of silicone tubing, a handful of isolation valves that I can use for a variety of things, and we're going to raise the temperature of the water in this tank before we start testing to 150 degrees Fahrenheit or about 65 C, pretty close to mashing temperature. I think that more closely represents what a home brewer would be doing with this pump than just doing cold water testing. You can use it for cold water pumping. They're rated for both, but I think most home brewers that are using this type of pump are using it in their hot liquor tank, their mash tun, or their boiled kettle. So let's turn it on. And what we'll do is we'll raise the temperature of the water to about 150. When it gets there, I'm going to isolate this ball valve. I'm going to take this triclover clamp off. I'm going to move it over to this clamp just above this bucket. Now it's going to serve as basically a discharge nozzle. So it'll be coming right off the pump, going straight into the bucket once I turn the pump on. The bucket itself is sitting on top of a scale. Now the scale is set to the kilogram scale, and conveniently 1 kilo of water is 1 liter. I know you're thinking 4 degrees Celsius is where water is its densest, right? Like around 39 Fahrenheit. That's where it's really 1 liter equals 1 kilo. However, the difference between that and say 150 Fahrenheit or 65 C is only about 2%. So let's not split hairs. For the sake of this test, this is going to be very convenient and an easy way to measure the output of this pump in a given amount of time. So what I'll do is once we get the temperature up, we will switch it over here. We will start the pump and the timer simultaneously. We will pump 25 liters of water into this bucket, and I'll watch the scale as we're doing it. When it gets around 25 kilos, I will stop the pump and stop the timer, and we'll check to see how long that took. We can do the math and figure out what the flow rate was very easily. We'll do a couple repeats on that, and then we will pour the water back in here. Make sure that we're back up to the same line so we don't have any weird effects in pump delivery due to head on the tank. And we'll repeat this with the Blichmann next. And then we'll compare the numbers and find out where we stand and find out how it works under real world conditions. So let's start doing that. We're going to turn the heat on. Start the pump. When we get to 150, we'll do our testing. All right, looks like we're at 150 degrees Fahrenheit, 65 C. Here's a view of the stand from another angle. There we go. Gonna kill the pump. All right, let's remove this TC clamp and isolate these valves. Minimize leaks. Make sure the scale is zeroed. It is. All right, we're going to open up the tank valve again. And now we can start running the test. Okay, we've got the Blichmann Riptide installed now. The water temperature is back up to 150. We've been recirculating. We've got out all the entrained air. The pump is nice and warm. Everything's ready to go. We just need to move this TC back up here. All right. Got it all set up, just like before. Let's do our tests. Okay, well that went pretty well. We did 3 passes with each pump. Let's go roll up the numbers and see what the results are. Okay, testing's done. We've plugged all the values into the spreadsheet. I'll display that in just a second. I thought it'd be good to explain real quick a couple of items in case people had questions about some of the other conditions of the test. Yes, every test was conducted at 150 degrees Fahrenheit or 65 C. I made sure that the temperature was correct at the beginning of every test. So every single test had the same temperature. I did take the water that was run into the bucket from every test. I'd return it back to the heating vessel so that there was identical head pressure at the beginning of every test. So it was the same volume being pumped, same temperature, and same head effects due to the fact that the vessel was filled back up every single time, so that the conditions of every test are identical. As far as the plumbing goes, briefly, yes, about 6 feet or 2 meters of silicone tubing. It was 10 millimeter ID tubing. I chose that because it was a good middle of the road value. I have some larger tubing. I have some smaller tubing. I thought that would be representative of a good middle of the road piece of tubing that a lot of people would use with your typical connectors. And all of the connectors, the gaskets, everything. The smallest connector had a 3/8 ID. That was a single connector. But everything else was 3/8 or larger. Again, the tubing ID was 10 millimeters, and so that was those were the conditions of the test. And so every single test that was run for both pumps was identical. So let's jump to the spreadsheet and take a look. There were not a lot of big surprises here, but there were a couple of cool observations, and let's take a look. Let me get me out of the way. I'm melting. Okay, there we go. All right, so everything in here is the Chugger results. Everything over here are the Riptide results. So real quick, here's the scale readings. Remember, we did this in the kilogram scale so that we could very easily use a scale to measure the volume of water pumped. This would only work for water, obviously, in this arrangement that we used. I know somebody's probably going to say, hey, if this was wort that you were pumping instead of water, the specific gravity would have been different, the viscosity would be different, blah, blah, blah. And absolutely right. There are so many different conditions that we could have tested this under. This was simply done to show what this pump does when compared to the other under these conditions. These conditions were hot water, 150F or 65C water pumped. We did 25 kilos or 25 liters of water approximately for each run. You can see where I recorded the actual value pumped, the actual time that it took to pump it. We break that down into seconds just for ease of calculation. And then from that, we can easily derive the liters per minute or the gallons per minute pumped. So that gives us our rates. And then I averaged them up down here. So you can see that as far as the chugger goes, 14.18 liters per minute or 3.75 US gallons per minute. The average head pressure developed was 208.03 inches of water pressure. A lot of these pumps are actually measured in feet of head, so that is, I intentionally did this in inches of water because it was a much finer scale. I could get a little better resolution with my gauge doing this than if I used a different unit of measure. So I used inches of water and then converted it to feet here. So you can see it was 17.34 feet of head on average. And if we take a look at how the chugger did versus its specifications on paper, we can see that the flow rating, it's rated for 7 gallons a minute, and it's rated for 18.6 feet of head. The flow rate actually came out to 53.5% of the stated 7 gallons a minute. Now that's not unexpected, and that's because, again, this was done with a plumbing circuit with some resistance intentionally introduced. It was done at an elevated temperature. And you can see also that the head, however, was 93.2% of its stated value. That's pretty decent. That's pretty accurate. So again, no surprise on the gallons per minute rating because of the way I ran the test intentionally. I expected to see a lower value than the ideal value of 7 gallons per minute. Now, so that's how the chugger stacked up. Now, if we look at the Riptide, it had the same rating, 7, but it also has a head rating of 21 feet instead of 18.6. So it has a slightly higher head rating. And this, you can see, let's jump over here and we'll take a look. Okay, so here's the 3 runs. Here are the times. Again, we break it down into seconds to derive our flow rate. And so here are the rates. It was 15.07 liters per minute for the Riptide versus the Chugger's 14.18. Okay. As far as the equivalent gallons per minute, it was 3.98, just about 4 gallons a minute out of the stated 7. Not bad, again, considering the fact that this was a hot liquid test done under duress through a plumbing circuit with some intentional restrictions in there. So, and yes, on the Riptide, the flow valve was wide open on all tests. So we can see if we roll it all up, you can see that versus the 7 gallon rating per minute, it got 56.9, almost 57% of that rating. So it beat the chugger as far as the delivery rate. And as far as the head rating, 99.4% of the stated head under these conditions. That's pretty good. And that also beats the chugger. So the reason why the Riptide, even though they're both rated at 7 gallons a minute for the chugger and the Riptide, I think the reason why, and this is my speculation, but it stands to reason, I think that the reason why the Riptide outperformed the chugger was because it does have the ability to work against a higher head. So in other words, if you need to pump against some restrictions, the Riptide may give you a slight leg up on the competitor there. So if we take a look at the final results here, if you look at it as Riptide versus chugger, the Riptide comes out ahead on flow by a little over 6.25%, 6.28% better flow under these exact conditions. And as far as head, 20.4% better head performance than the chugger. So that's pretty impressive, actually. So it's not a huge difference. On brew day, you're really going to see a difference between these two pumps? A little bit, maybe. If you have some restrictions and some additional challenges in your plumbing circuit, the Riptide's going to do better. No doubt about it. These are the pumps that I use. I really like them. I also like my chugger. And in a subsequent video, look for a video after this one. I'm going to take this chugger, this one that we have the results for right now, and I'm going to convert it to a Blichmann Riptide with the Blichmann kit. Then I'm going to rerun the new configuration of that pump against the original Chugger, and we'll throw that up in a spreadsheet and show you how it compares against its original configuration and an off-the-shelf original Blichmann Riptide. So that'll be interesting. So look for that in the next video. So what do we get out of this? I think that, again, not a lot of surprises, but there were some interesting finds in here. Some I expected to see. Some were much better than I thought. But what I really take away from this is, if you look at it from a value standpoint, in my opinion, the Riptide beats the Chugger, although they're both very capable pumps. They've both been around for a bit. For the price point, there's only about a 10 to 20% difference between the Riptide and the Chugger. The Riptide's more expensive to the tune of 10 or 20%, depending upon which configuration you buy. Is it worth that extra premium? Well, it's not a huge premium considering, and again, this is my opinion, but considering the added benefits you get when you get a Blichmann Riptide. When you get the Riptide, you have the bleed valve, right? So you have that little poppet that you can pull to prime the pump, something the Chugger does not have. And that makes a big difference on brew day. If you've ever went to fire up your pump and heard it squeal and realized, oh shoot, my pump is dry. Yeah, you have to get liquid into that pump somehow. So that can be a pain. Usually you have to introduce a separate valve somewhere. In this case, on the Riptide, it's part and parcel with the pump itself. It's built into the pump. So you just pull the ring, you burp the head of the pump, and you're off to the races. The other thing is the built-in flow control. Really nice feature. And I do use that. That is awesome when you're mashing, just for example. The fact that you can throttle the output. And yes, it's on the output, which is where it should be on a pump. And so that, and the fact that it breaks down extremely easy. You have one TC clamp, you spin it off, boom, the thing's open, no tools. I really like that. And I like the fact that because the pump head is mounted to the motor, with that arrangement, it just by default, it makes the angle that you can turn the pump head continuously variable with respect to the motor. That is really handy. I know in my brew bench, it does make a big difference because I do have to tip a couple of my pumps at a different angle. I use 2 of these in my brew bench, and I have 1 spare. So anyway, the way I see it shakes out, these 2 pumps are both highly capable. I think the Riptide is worth the slight premium that you pay. It's not a huge premium. Like I said, 10 to 20%, depending on which one you buy. And what you get in return, I think, is well worth the extra expenditure. So that's how I look at it. Anyway, hope you think this is helpful. Thanks for tuning in to Halfmoon Tech Labs, and look for that second video coming up shortly. Thanks, and we'll see you later.